Okay, welcome to a very noisy part of Dubai at about 8 o'clock in the morning. I'm standing here on the edge of Sheikh Zayed Road, which sounds a little bit crazy, but it is to introduce you to today's task to be a civil engineer for a day. This is all about our built environment. So whether it is creating huge transport links like Sheikh Zayed Road or these massive pillars that are supporting the infrastructure, transport infrastructure that bring people around the city, that makes the city so vibrant, so lively, and such a crazy environment to work in. That's what civil engineers are doing. And what is fantastically interesting about Dubai is how new a city it is. It started with an idea many years ago and it grew so very quickly. It has been a dream for architects, for engineers of all different hues to get involved in the story that is Dubai, bringing these amazing infrastructure properties together to deliver this city. But today's task is going to be about what underpins that whole endeavor. It is about the civil engineering. And while we could have chosen many different aspects of civil engineering, we're going to look at the very fundamentals. We're going to look at the foundations that underpins every part of every infrastructural piece that we have here in Dubai. And I'm lucky to be joined today by our expert civil engineer, Wendu. Wendu, I was just saying there that one of the more fundamental things to all delivering these huge infrastructure projects is going to be the actual foundations. We could have chosen, right? We could have chosen any aspect, but the multiple aspects of civil engineering here, from the large scale structures to the transport links, anything from civil engineering. But what we chose today was to start at the very beginning, I would say, which is the foundations, what underpins every infrastructural project we have.
Right. So so what you see here is a bit of soil material.
Yeah.
But that is actually quite loose, sandy material. But if you look globally, the nature of soil, the nature of the ground conditions varies. So you could have something which is quite granular in nature to something which is quite rock in nature. You can have things like clay material and a range of different types of
So would you say a particular challenge here in Dubai then is to build a city like this on what I would have considered fairly loose footings on sand, right? Is
Yeah.
that a particular challenge?
That's a particular challenge because sand in itself is actually quite slippery.
Right.
Yeah, because there's not much friction between the particles of sand. So we need to be able to actually compact it in order to give it a bit more stability.
And I know that's part of today's task is to look at the impaction and how you're going to deal with different materials to create quite solid footings for what are huge structures. I can only imagine the pressures that these footings or these foundations have to take.
Yeah.
And you were explaining to me earlier, some of our high rise. Let's take the Burj Khalifa, for example, an absolutely massive building built on, I guess, sand originally. So how is it that you can realize a huge infrastructure project like that from, well, sand grounding?
Well, we wouldn't put the foundation of the Burj Khalifa on top of that material.
Okay,
What we will do is we'll try to go deeper
right,
and look for harder material
right.
on which we can actually bear the Burj Khalifa.
So, and going deeper, does that mean more basements? Does it mean, driving piles till you get to a more solid foundation? Or?
Yeah, that's exactly right, Tyke. So basically, we will do some sort of ground investigation before we start off to understand the different layers of what's on the ground and what's underneath the ground. And then we can determine what strata is actually strong enough to bear the piles for the Burj Khalifa.
Strata, complex word, strata. Strata meaning like layer upon layer?
Exactly, layer upon layer. So you've got the earth's crust, but beneath that you've got harder material.
Okay.
Beneath, what we need to do is to get to hard rock material in order to be able to bear the piles that we dig deep into the ground.
So the first thing you do, you have this ambition to deliver some huge building. The first thing you do is must be some sort of survey of the geology of the land that you have to work with.
Yeah, exactly right. So what we'll do is we'll dig boreholes into the ground. It's just like oil.
Exploratory.
You do some exploratory investigation.
Right.
So you dig boreholes and then look at the cores.
So you take a core sample up out of the ground.
Exactly. And then you begin to understand what the nature of the ground is.
And that must be one of the first things that we have to
That's
do in our
absolutely
planning.
the first thing you've got to do. I mean, what you might see on a new site would be lots of drilling rigs.
Yeah.
And basically what they're doing is they're drilling into the ground to get samples of cores to understand what the nature of the ground is.
Excellent. So that's one particular challenge that we would have in Dubai, but I'm aware, of course, engineers, well, they design for very different environments. Here in Dubai, one particular challenge with perhaps sand as your footing, whereas different parts of the world, maybe you're lucky enough, I'm going to suggest, with a rocky surface or core sample, whereas other parts of the world, perhaps I'm more familiar with, are going to have a higher water table, a lot more water in our earth and soil and clay.
Yeah.
Similar challenge or a very different one?
It's a different challenge because obviously if you've got areas where there's clay, as you mentioned, or there's peat, then you've actually really got a problem with expansion. I mean, things like peat, clay materials tend to absorb a lot of water.
Okay.
And as a result of that absorption, we tend to expand a lot.
Yeah.
So we need to be able to understand what do we do with those kind of materials. Possibly we get rid of that obstruction and make sure that when we build the foundation, we're not building it on peaty material or on soil material. Other things we could do would be to lower the water table, for instance.
Okay.
So you could dredge out the water.
Dredging out the water.
Exactly, until you get to a level where the water table is low enough not to impact upon your building.
So excavation and dredging, and then there must be some sort of retaining walls or something to keep that water out.
Yeah. So we tend to have what are known as casings.
Casings.
Yeah. And these will tend to be used during construction to keep the water out until we can actually put the actual structure in there. And then once the structure is in place, then we can actually take these cases out because we've got the permanent structure that will carry the superstructure.
So I'm interested then to perhaps link a little bit towards the task that we're going to look at today, which is about the preparation of that solid footing. So we have our boundary conditions, we have our starting position and what we have to deal with, but inevitably you're going to have to put something down. You need to start putting aggregate down, you need to begin to compact that aggregate to be able to take the load that you want. Is it the same process that you do in very different environments, or what are the different design variables that we have as an engineer? Do we get to choose our aggregates, the pressure? What can we do to design a solid footing?
Well, there's a range of things you can do. Ideally, what you want to be doing is not have to, let me say, you probably want to keep your costs down. You want to think about the sustainability of what you're doing.
Cost is definitely a factor. It has been in just about every engineer for a day we've done. So anything in design, we're always aware, of course, about cost and sustainability.
Right. Okay. So if we can not have to import as much material in order to make the soil better, then that's a good thing.
So that also speaks to the sustainability
That
factor.
speaks
So
to
you want to use your locally available materials.
Yeah. I mean, if you could use recycled material, for instance, to stabilize your soil, then you're on a winner there. If we have to start manufacturing other materials in order to stabilize the soil, then that kind of moves away from the whole, ethos of sustainability.
Yeah. And I suppose the idea of recycling of materials is a very commonplace now, as buildings do eventually come down, are demolished, and have the potential to be, is it upcycling then and put into new
Well,
forms?
there's the upcycling side of things, but I look around us and I see all these buildings.
Yeah.
I call them urban quarries.
Urban quarries.
We've got natural quarries, but we've got these buildings at some stage in the future will be demolished. And I think we do need to understand what stock of these materials we've got, so that in the future we don't demolish and waste these materials. We find a use for the use of these materials.
Another question for another day, but that's when we look at the full life cycle of design, from the extraction of raw materials to its building and operation to its eventual decommissioning.
Yeah.
So if those are some of the broader ideas about the use of materials and the cost implications, and a bit more on the technical side, what are we looking for in aggregates in terms of their strength of materials and you were mentioning how slippery sand can be. What are the other factors we have to consider as part of our design?
So I guess things like the size of the particles that we're
Particle
using,
size, right?
the shape of the aggregates.
Shape, all right.
So the rounder the aggregates, the less stable they tend to be because
Okay.
there's a lot more, there's less friction
Yes.
between more rounded particles. Um, the other thing that we're looking for is a distribution of particle size because what that does is it gives it a lot more compatibility, a lot more stability.
Yeah.
Yeah.
And anything then about, I don't know, moisture concepts or adhesives that help to
Well,
work together?
you've got adhesives. So a common adhesive is cement.
Yeah.
Another common adhesive, you look at roads,
Yeah.
is bitumen.
Bitumen.
That's another common adhesive. But we tend to use these in a fit for purpose application, not because we've got cement or we've got
Yeah.
bitumen. Then we say let's apply this. We need to make sure that we're applying it because it's fit for purpose.
So it's just one of the factors that need to be considered in the design, but it's also there as part of your choices of all the things that need to be designed in. One thing I've always been really keen to show is that engineers design, right? So it's about understanding what variables you have and what you want to achieve.
Yeah.
And then making the most of those variables so that your design is optimal. So optimally, not just so that it works, but optimally because of sustainability and all sorts of factors like finance and economics.
Yeah. Yeah.
Excellent. Thank you very much, Wendy, for that. Just to end on this introductory section, you can see the challenge that are there for civil engineers. You can see the amazing environments they've created. I've neglected to show you the Museum of the Future, which in and of itself is a civil engineering and architectural engineering marvel. These are just some of the challenges, some of the disciplines in which civil engineers and engineers in general work in. I hope you enjoy this task. You get some insights into the role that a civil engineer has to play in developing and realizing incredible infrastructure projects like we have around us today. Good luck on the task.
My name is Dr. Noor Habib. I'm assistant professor at Heriot-Watt University, Dubai campus. Today we are going to perform an activity to share something more about the soil. And what are the things that we are going to do in today's activity? It's a very simple operation that you have seen everywhere, that is the soil compaction. So let's start that what is the purpose of the soil compaction and why it is being required. Soil is basically composed of the heterogeneous material and it has the different sizes of the aggregates. And what aggregates are? These are the aggregates that is being commonly used or can define the soil. These are the broken pieces of the rocks that, or you can say the parent rocks, and that may be transported to the other part by means of the weathering or erosion. So now what we are going to use to this, that we are going to define that why we need to compact the soil to make it stabilized so that massive structures can bear the load of the massive structure. Today, when I'm going to speak about the soil compaction, as I have told you, we are going to perform an activity that is related to the soil. The soil compaction is basically bringing the soil particles together. When I'm speaking about the soil particles, these are the soil particles. Soil particles comes in the different shapes and sizes. As you can see, I can see this. These are the soil particles which are irregular in shape, and even you can figure it out that the color is also different. So in today's activity, we are going to perform soil compaction. And why do we need to compact the soil? What is the purpose of the soil compaction? These are some of the questions that may arise in your mind. So let me handle one by one. So one of the things that is common in all this question is that soil. And soil is a mixture of aggregates. And what are the aggregates? These are known as the aggregates. So you can see these are the coarse aggregate. This is a mixture of the coarse and fine aggregates. And this is very simple fine sand that we call it as a dune sand. You all knew this because this is abundantly available in abundance all over in Dubai. So we are going to deal with this. Okay. Now, as I told you, we are performing the soil compaction. So what is the purpose of the compaction? Compaction is a mechanical process. not natural. When I'm saying it is a mechanical process, it means that you are going to use any kind of the mechanical equipment that it brings the soil particles together. And the reason for to compact is to increase the strength of the soil, or you can simply say the bearing strength of the soil. Now, another question you may ask me is that why do we need to increase the bearing strength of the soil? All your structures, whether you have willing to construct a structure like a Burj Khalifa, whether you are interested in to construct a bridge, whether using to construct a dam, whether you are willing to construct a road or highway, it's all resting on the ground. And what really your ground is, it is basically is the soil. In other words, or in the simple words, you can say it's a soil. So you need to prepare your soil up to the point that it can bear the load of your structure. And the first and the foremost, or you can say the simplest thing that you need to start is the soil compaction. So in today's activity, we are going to perform how we can compact the soil. So as I have told you, soil compaction is a mechanical method of bringing the soil particles together, and that is why you came across there are so many different types of the mechanical equipments are being deployed to the site where the construction is in process. So you may come across like a rollers, which is basically is used for compacting the roadways. You may come across like a big crane which is dropping the weight from a height. That is the dynamic compaction. But the one thing that you can say is that these are the mechanical means. So, soil compaction is a mechanical method. Let's start with the simplest activity in which I will explain you how we can create a soil compaction in our lab. First of all, you need to know what these aggregates are. These are the aggregates that I have collected, and these are considered to be the coarse aggregate, fine aggregate, and a mixture of fine and coarse aggregate. Okay. Now what I am going to do in today's activity, let me take a simple container. This is a simple plastic container. Otherwise, we can use the other containers also, but to be on the safe side, I took a very simple compactor, soil containers that are plastic. So let me explain you one by one. Now I am going to take some scoop of these aggregates, which are the coarse aggregate, I am saying. Let's start compacting of the same size of the aggregate. So in this container, which is a plastic container, I took some amount of the coarse aggregate, a larger size aggregate. Usually we call it as a gravel. So you all know this about it. I put a small quantity of the gravel, and these are in the loose state. What is the meaning of the loose state? Meaning of the loose state is that I just transferred the amount of the gravel from here and without any compaction into this plastic container. Now, measure the height. What compaction is going to do after this? These gravels are in loose state, or you can say that they are in the coarse aggregates are in the loose state. These are not even. Can you see? If you can see, these are not even because I just place it in the container. Now, what I am going to do is that I am going to do a sort of a compaction. And this compaction is in your daily life, you already perform everywhere in every house, and you saw your mothers doing this. They used to tap it on the tabletop. So what would happen? So if when you provide some kind of the tapping, these loose aggregates which are sitting randomly, now they are going to settle themselves into the spaces which are available. For example, if you can see in these aggregate, there are different kinds of the aggregates and they have the different shape. When you provide this compacted by simple tapping on this table, they rearrange themselves, or what you can say is that from the loose state, now they are going to convert into the compact state. This is the simplest example that I gave you. Now, this is for the gravel. Now, you can see also that previously my aggregates were initially at over here. Now, it has reached the position. So I did not perform any kind of the mechanical compaction. I did not apply any force. I did not apply any kind of the mechanical equipment. The simplest things that I did is that I said tap on the road, and what happened in this, these aggregates or the gravels rearrange themselves or from the loose state to the compact state and forms a denser aggregate structure. Now, the same way you can do it with this sample of the Jabal Hafid sample that we get it from the Jabal Hafid. It's a mixture of the fine grained soil, coarse grained soil, and the aggregates of the bigger sizes. Now, initially I took in the loose state, I transfer it. Now, this is in the loose state. This is in the loose state. Now, what we are going to do is that we are going to tap it again. No, first of all, you need to mark it. I really need to mark it the first stage where is the level is. Now, compact it. Now, as I can see from my side, maybe you won't be able to see it, the new position of the gravel is here. So this much difference, the difference between the top line and the bottom line gives me the idea that after compacting it by simply tapping on the table on this, it has compacted and it has rearranged, the particles has rearranged itself from the loose state to the dense state. Okay, so this is the simplest examples that I gave you with respect to the compaction. Now, same thing that you can perform this activity with the fine sand. Take an empty container, place some soil. This is the dune sand. Just level it. And you can mark the level of this. Now, simply start, tap it on the, no other mechanical mean, no weight, nothing. I'm just tapping it on the table. So, while tapping, you need to be very careful if you are using any kind of the kitchen ingredients. Be careful that this should not be the glass tabletop. Otherwise, you know what would happen. Okay. So now I can see that the new positions that is being achieved after the compaction is here. So the simplest amount, the change in the height from this point, the first point where the level was, to the next point, this point, it means that this much soil has settled. And why this has happened? Because soil has rearranged itself. So it will give you a compact soil. Okay. So this is the basically soil compaction is nothing, just the rearrangement of the soil particle from the loose state to the dense state. Now come to the position where we are going to mix all these three aggregates, and then we will see that how the compaction can be achieved. Just transfer the amount. Take a handful amount of the coarse aggregate. Some sample of the Jabal Hafid. Dune sand. I took equal proportion of this. What are we going to do it now? Now I'm going to simply mix it. You can do this mixing in any kind of the bowl if you are using the kitchen equipment, just to have a feeling that how compaction can be achieved or how you can increase the density of the soil. So I'm just going to mix it. So I have mixed this. So you can see now the gray color sample. This is the coarse aggregate of the gravel I told you. This is the sample. This sample, the top one that you can see is from the Jebel Hafid, and now you can no more see the dune sand, which is of this color. Can you see? This is of this color. Now you cannot see any one of this. Now, what I am going to do is that simply is that again measure the volume. We are not going to measure the volume just using the simple marker. What you are going to do is to mark the level in the container, this level of the soil in the container. Now, again, simple, nothing is being used. I'm going to tap it. 1, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, after tapping it for the 15 times, it means that I have applied some kind of the mechanical energy. Now, the new level of my soil is this much. Okay. Now, if you look at it, if I want to penetrate a pen in this, it can easily go inside it. It means the soil is still in the loose state. It is not in the compact state. Okay. So, again, what I am going to do is that by applying the simple tapping. So, after tapping it for the 15 times, I can measure soil has settled up to this point. So, it means that soil is filling up the different kinds of the aggregate sizes that are being inside in this. They are rearranging themselves according to the points where it can fill in the gaps. So, now you can see that the soil has done. But again, I would say that my pen is showing a bit of the resistance. It could not penetrate through it. Now, how to achieve this? How you can further improve the density of the soil? How you can bring the soil particle closer together? So, you need to use some kind of the mechanical hammer. So, these hammers which has some weight, over here this is a dummy hammer which does not have any weight, but usually in the soil compaction process you see that the rollers has been used or some kind of the dynamic compaction has been employed on the side to compact the soil. So, one thing that I am just giving you an example is that I am going to apply the simple tamping. So, 15 times I have tapped this soil, and after this what I got is that if I really want to, still it can penetrate. Why this is happening? Why this is happening? Because the soil is still in the loose state. So, it means that you need to apply more effort to increase the density of the soil or to compact it. So, the rest of the thing is that we can add some water in it. So, better to, I should take some more. And use this. I pour some water in it. And this mix sample. What the water will do? Okay, now I have got this sample of the soil. A small amount of the water has been added just to keep it moist, not a huge amount of the water that. And now I am going to compact. What I felt is that what I have noticed is that initially, which was my sample was here, now after adding a small kind amount of the water, we can better compact it. What is the reason behind it? Water acts as a lubricant, and water allows the soil particle to slide past each other and we can compact it. So if we can, just going use my pen. This pen could not penetrate. The soil is providing the resistance. So it means that soil has reached a better dense state just by adding a small quantity of the water. And this is one of the reasons that you have seen in all the construction of the roadways where they are compacting the soil by using the rollers. They usually spray the water during their compaction process. So that is this very small version of the compaction that I have shared with you by the simplest ingredients that you have in your home. At your home, you can practice this, and by using the simple aggregate soil aggregate. Thank you very much from my side.
So we started today's task as a civil engineer for a day on Sheikh Zayed Road. And we're looking at the huge infrastructure that there is in Dubai, from the rail and highways to the amazing buildings and the Museum of the Future where we started. But obviously it all starts from the ground up. We need to be able to work with the ground that we have to realize these huge projects. And that starts with materials. We looked at different aggregates and how those go together, designing the geotechnics to create these very firm foundations to build these really impressive structure. I hope today you've been able to experiment, to see how different combinations of aggregates can go together to create very strong foundations. And I hope you've gotten some insight in what it might be like to be a civil engineer for a day. So we really encourage you to engage again with this task, to show us your designs, show us what you've managed to create, and we're very happy to send you a certificate of participation. And we hope that you'll join us again to be an engineer for a day with Heriot-Watt University.